Hi, welcome to this lesson in algebra, logarithms. What are logarithms? Well, in algebra, we've encountered the normal algebraic operations that we use, such as addition and multiplication. And we have learned how to undo these operations by using the inverse operations. So for addition, that would be subtraction, and for multiplication, that would have been division. Well, when we have variables as an exponent with some base and we want to solve for that variable, we use the technique of matching the bases on either side of the equation to solve for the exponents. So for example, when you were asked to solve 2 to the power x equals 32, traditionally we would rewrite 32 as a base with 2. So there'll be 2 to the x equals, or 32 is 2 to the power 5. So because the bases were equal, we could therefore equate the exponents. And that was the way we've learned how to solve exponential equations up to this point. But what happens when we cannot match the bases on either side? Well, we can use the inverse operation of exponentiation, which is called the logarithm or the logarithmic operation. Consider the following equation. B to the x equals a. So remembering that b is some number, which is your base, x is some number, which is your exponent, and a was some number that you needed to solve for. To solve for x in the exponent, we define a new type of algebraic operation called the logarithm. We can rewrite the equation b to the x equals a as follows. We will call x a very special type of number. We will call it the logarithm with base b of that number a. So this b was your base, a was the number that you were solving in the original equation here, and x will give you that exponent number that will satisfy this equation. Let's have a look at an example. Solve for x if 2 to the power x is equal to 5. Now we cannot rewrite 5 with a base 2. So we can't say that 2 to some nice natural number like 3 or 4 or whatever, that'll never equal 5. So we must use the logarithm to solve for our variable. This is done as follows. The logarithmic operation is applied to both sides of the equation. And this number, log base 2 of 5, will just leave us with the variable x that we need to solve for. In order to do this, we will need our calculators. So, on our calculator, what I'm going to do, so let's just make sure everything is good, that you'll have a logarithm button here on the top right, next to this inverse button. So if you click that button, you can put log base 2, so the base goes underneath and the number goes inside the bracket. So log base 2 of 5 equals, and we get that number there, 2.3192895, so on, so on. So what I'm gonna do is shift store in A. I'm gonna call that number A because I want to check that this satisfies the original equation. So 2 raised to the power of this variable number that we solved. If I press equals, I get exactly 5. So that number, A, 2.3219, so on, is the exact value of that power exponent that will satisfy this equation. And that is the power of the logarithmic operation. So just as we have our exponential laws that tell us how to multiply, divide, and distribute exponents, we have a similar set of laws that tells us how to work with logarithms. So the whole purpose of logarithms is to help us solve exponential equations. All right, and we'll be discussing those laws in the next lesson. All right, I'll see you in the next one.